Just want to do one quick last problem. I'm going to try to fit this in under 2 minutes. This is a conservation of angular momentum. Symbol for that, L. Conservation of angular momentum means that whenever you change the shape of an object or you add mass to it, you are going to change how quickly it is rotating. We saw some examples of this for the people in class standing on the sphere whenever we did the bike wheel, and whenever they moved the masses inward. So let's pretend that we have a figure skater, and that figure skater started with their arms way out like this. They have very long arms according to my drawing. And their initial moment of inertia was something on the order of, I don't know, let's make up a number, 100 kilograms meters squared. And they were initially spinning with an angular velocity of 4 radians per second. Later on, as they're spinning, they tuck their arms in. They tuck their arms in and they spin faster. The reason being is they've changed their moment of inertia to something like 40 kilogram meters squared, and we can find their final angular velocity. These are over here are all initials. The way we do this is simply by recognizing that the angular momentum of an object is conserved. The initial angular momentum must equal the final angular momentum that we have, and angular momentum is just equal to I times omega. So our initial quantities have to equal our final quantities. And that's basically it. We just need to plug stuff in. For our initial moment of inertia was 100, initial angular velocity was 4, equals, our new value is 40 times some final, which we don't know. If we solve for that, we are just going to divide each side by 40. This is actually fairly straightforward to do. We know that 100 times 4 is going to be 400, and 400 divided by 40 is just going to give us 10. Another way I can do this is recognize that this is going to become a 1, this is going to become 10, and then the zeros cancel out. So we end up finding that the final velocity is equal to 10 radians per second. It used to be 4, now it's 10. We're spinning faster, okay? You can do this all sorts of ways. You can change the moment of inertia just by changing the orientation of it. You can change the moment of inertia by sticking two objects together, in which case your final moment of inertia is just the addition of the moments added together. So take a sphere's moment of inertia, 2/5 mr squared, and add it to a cylinder, solid cylinder, 1/2 mr squared. Add them together, you got a new moment of inertia, boom. Angular momentum must be conserved. With that, this problem is finished. Take it easy. Go Pens. Okay, I think I'm going to leave this stream.